Okay, so let's move into trig. The first item we're going to deal with are angles and their measurements. So here's the thing. I know you know all about angles because you dealt with them in geometry and everything else. But I need to go over some basics to make certain we're all on the same page. Okay? All right. Now, clearly, here is our angle. Some of the verbiage that goes with it. This is known as the initial side of the angle. This is considered the terminal side of the angle. And what we're assuming then is the angle opens in this particular direction. One other item that we need to make certain we know is this is considered the vertex. Now, here's the deal. Now that we have all the sides of the angle labeled, let's talk about the standard position of an angle. Because that's important in trig, is to understand what standard position is for an angle. So here is our XY axis. The initial side is always on the positive side of the x-axis, and the vertex is always at the origin. Got it? Which means my initial side is right here, and my vertex is at the origin. Now, two things. If my angle opens in the direction of the labeling of these quadrants, you're like, wait, what? Let me refresh your brain. Quadrant 1, quadrant 2, it goes counterclockwise, doesn't it? Quadrant 3, and then quadrant 4. So, if your angle opens in the direction of the labeling, which is counterclockwise, then this is considered a positive angle. If your angle opens against the labeling, so it's going in the clockwise direction, it goes against the labeling, then this is considered a negative angle. Are you with me on that? Okay. Now, also want to make certain we remember, since the initial side is on the positive x-axis, then this is where our 0 degrees will start, on the positive side of the x-axis. Now, these two axes, our x and y axis, are perpendicular, are they not? Which means they meet at a, excellent, 90-degree angle. So, if 90 degrees is here, and I'm opening with the direction of the labeling, because the labeling is counterclockwise, if I go in the counterclockwise direction, the direction of the labeling, then this up here would be 90 degrees, wouldn't it? If I continue in that same direction, this is still 90 degrees. This would be 180 degrees, wouldn't it? If I continue still in that same direction, counterclockwise, the direction that we're labeling the quadrants, this would be 270 degrees. And then we would finally end right back up here at 0 degrees, which now has a full measurement of 360 degrees, doesn't it? Okay. Something else I'd like you to look at. Let's start again at the positive x-axis, right? And now I'm going to go in the clockwise direction. I'm going to go against the labeling. Now I'm going to go backwards to the labeling. This is still 0 degrees. This is still a 90-degree angle, which means when I go in this direction, I'm now at a negative 90 degrees. If I continue in that direction, over here would be a negative 180 degrees, because this is still a 90-degree angle, agreed? If I continue in that clockwise direction, that direction that goes against the labeling, then this would be a negative 270 degrees. And finally, when I continue, I would be here at a negative 360 degrees, wouldn't I? So understand something. This is our circle, because a circle is 360 degrees for one reason. If we connect all these quadrants together, shall I say, we come up with a circle. And the reason it's a positive 360 degrees is because we're going with the labeling of the quadrants. If we go against the labeling of the quadrants, then we're at a negative 360 degrees. Are you with me? Okay, one last item that I want to look at while we have these quadrants up here is this. There is another measurement for us when it comes to the measure of angles. And that other measurement is known as radians. We're used to dealing with degrees, which is how we just labeled this. We labeled this in degrees. But there is a second measurement known as radians. Now, believe it or not, you've been dealing with radians. And you're like, how so? Well, you may not have realized it, but every time you dealt with finding the circumference of a circle, you dealt with radians. So I'm just going to clean this up a little bit so we have a little more space to work and it doesn't look so cumbersome. Remember the formula for the circumference of a circle? You getting that in your head? What is it? Yeah, that formula was 2 pi r, wasn't it? To find the circumference of a circle, it was 2 pi r, wasn't it? What did r stand for? R was the radius. Well, here's the deal. 2 pi was the full circle measurement in radian measurement. A full circle is 360 degrees. A full circle in radians is 2 pi. So, one full circle is equal to 2 pi. In degrees, it's 360 degrees. So now let's take a look. Okay? 0 degrees, well, that's not going to be any surprise. 0 degrees would just be 0 radians. Cool? Okay. And as we already discussed, one full circle, and we've already dealt with it, is 2 pi. Now, question. If I go halfway around the circle, and I'm going to go in the positive direction, that's why I left that up there. If I go in the positive direction, halfway around the circle, 2 pi, halfway around would just be pi, wouldn't it? Good. So give me a hand here. What's halfway between 0 and pi? I'm going halfway. That's right. So it's pi divided by 2, isn't it? And over here, this is another halfway, isn't it? So that's another half pi, isn't it? Because from 0 to this positive y-axis, we figured out was pi over 2, didn't we? Well, pi over 2 and pi gives you 3 pi over 2. With me? Okay, so we've learned how to label this grid system with our degrees in the positive direction and the negative direction. We've also figured out that the other measurement, known as radians, that we've actually already dealt with it, and we know one full circle has a measurement of 2 pi. So based upon 0 and halfway was pi, and half of that was pi over 2, and another half gave me 3 pi over 2, and back up. Are you with me? Okay, so one last thing I want to discuss here while we have this grid system. We have some conversions that we actually now know. One conversion is this. I know that 2 pi is equivalent to 360 degrees because we said one full circle. Based upon our labeling, I also know that pi is equivalent to 180 degrees. Based on other labeling, I know that pi over 2 is equivalent to 90 degrees, and I know that 3 pi over 2 is equivalent to 270 degrees. Now, when we start converting, I've got these 4 conversions. When we start converting from degrees to radians and vice versa, let me ask you something. Do we really want fractions in our conversions? No, we don't. So these last 2, though they're accurate, we would not use when we want to convert, because we don't want to deal with the fractions. No offense to the fractions, but we want to keep things as simple as possible. So we would not use these bottom 2, which leaves me these top 2, right? Now, do you notice the top one is twice as large as the second one? Yeah, the second one is the reduced form, isn't it? If I divide the top one by 2, I get pi and 180 degrees, don't I? So this is the conversion we're going to use. When we want to start converting between radians and degrees and vice versa, that's the conversion we're going to use. It's already in reduced form and there's no fractions to it. Got it? Okay, so hang in there. We're going to do some. Okay, so let's do some converting. So we want to convert these first 2 into degrees. So remember the 4 conversions that I wrote down over here. The best one to use is pi equivalent to 180 degrees. Now, I don't know how you were taught to convert, but when I was taught to convert in a high school chemistry class, it was the easiest process I ever found, and I never forgot it because it wasn't really based upon the numbers. It was based on the units. Are you with me? And by the way, if you mean to write degrees, you better put that degree symbol. Otherwise, if you don't put it, it's automatically assumed to be radians. FYI. So, if I look at this first one, since there's no degree symbol, I know it's in radians. And the one thing that truly makes it in radians is the fact that we have pi in there. So here's what I learned in a high school chemistry class that I never forgot because I found it super easy. So I am going to multiply, and I'm basically going to multiply fractions. That's going to be the easiest thing for me to do. Now, the pi, in my mind, is indicating that I'm in radian measurement. So do I want to keep the pi, or do I want to get rid of it since I want to go to degrees? Correct, we want to get rid of it. So with this conversion, I'm going to put the pi in the denominator. And some of you are going, why? Because I can cancel the pi on the top with the pi on the bottom. Which means the 180 degrees goes on the top. Are you with me? So now what I need to do is I need to basically multiply these 2 fractions. 5/12 times 180 degrees over 1. And I'm going to do some cross canceling. And this will give me 1 and then 15 times. Are you with me? Which means I end up with 75 degrees. So 5 pi over 12 would be equivalent to 75 degrees. Good? Okay. By the way, 75 degrees is in first quadrant, isn't it? Because first quadrant is between 0 and 90 degrees, isn't it? Which means 5 pi over 12 is also a first quadrant angle. Cool? Okay. Let's look at the second one. We're at negative 2 pi over 3. And again, I want to convert to degrees. I don't want these radians here. And what makes me think I have radians is the pi on the top. So I need to cancel that pi, which means on the bottom I'm going to place pi. Because the pi on the top and the pi on the bottom will cancel. And I'll have the 180 degrees left on the top. Which means I am basically now multiplying a negative 2 over 3 times 180 degrees over 1. And yes, with fractions we're going to do some canceling, are we not? That goes in there once, that goes in there 60 degrees. So what you're telling me is negative 2 pi over 3 is equivalent to a negative 120 degrees. By the way, can you guess which quadrant that would be in? Think about it. Negative means we're going clockwise or going against the labeling. So if this is 0 and I go to that y-axis, that's negative 90, isn't it? And I go to that negative x-axis, that's negative 180, isn't it? Degrees. Which means this is a quadrant 3 angle. So this one was quadrant 1, and this one is quadrant 3. Which means negative 2 pi over 3 is a quadrant 3 angle. Cool? Okay. Let's look at these next two problems. They want us to convert them into radians. I have them in degrees. So, same thing. I'm going to basically be multiplying fractions. Now I'm trying to get rid of the degrees, aren't I? So which one of these goes on the bottom? Yeah, the degrees goes on the bottom because degree cancels degree, which means the pi goes on the top. And now I basically have a simple fraction to reduce. Agreed? Okay, so when you start reducing this, let's see. I'm going to reduce by 4. 4 goes in, and then 4, this is what I get. So, that's a lovely looking fraction, isn't it? Well, so be it. By the way, 112 degrees was which quadrant? Yeah, that was quadrant 2. So 38 pi over 45, that's also quadrant 2. Cool? Let's look at this one. Okay, again, we're basically multiplying fractions. And I've got degrees on the top. Do you want them there? No, you want to get rid of them, don't you? So that means the 180 degrees on the bottom, so degrees on top and degrees on the bottom cancel, don't they? And then you're left with basically simplifying this particular fraction, which, what does that give you? Yeah, that gives you negative pi over 4. Now, negative 45 degrees. That means we started at the positive x-axis and we went against the labeling. We went clockwise. So negative 45 degrees is which quadrant? Yeah, that's quadrant 4, isn't it? Which means negative pi over 4 is also quadrant 4. Just trying to get you used to thinking about the quadrants as well as the degrees and the radian conversion. Good? Okay, so stay tuned. I have another type of conversion for us to use, and it's mainly for those people who like their GPS system. Okay, so let's talk about another type of conversion. Degrees, minutes, and seconds. So for those of you who are pilots or experienced boaters, you already know about the degrees, minutes, and seconds. This is our GPS system. This is what it's based on. And if you ever look at a world atlas, they have things or markings that look like this. Pretty much the two of those. They may have a third one. And so those markings will tell you where you are on the world, so to speak. Now, first thing I want you to understand is we're going to talk about the degrees first. So, 1 degree. And since it's minutes and seconds as the latter two, I need you to think of a degree as an hour, is what I need you to think about. Okay? And I know that sounds a little bit silly, but I need you to think of a degree as an hour. Okay? And that's 1 hour. Because here's the deal. If I want to take 1 hour and I want to see how many minutes are in an hour, that's 60 minutes, isn't it? So 1 degree is equivalent to 60 minutes. Notice I put 1 tick mark. 1 tick mark means minutes. So remember that. 1 tick mark means minutes. Notice the other one is seconds. So 1 minute is equivalent to how many seconds? Good, 60 seconds, which is a double tick mark. This is how the World Atlas is labeled, with these particular pieces of the puzzle put together to give them a GPS coordinate so that they can track down whatever it is they're tracking down. Cool? Okay, so here's what I'd like us to do first. Here's what I'd like us to work on first. I would like to convert to degrees. And here's the first problem I would like us to convert. I'd like us to convert 20 degrees and 54 minutes. Now, if I want to convert to degrees, I'm noticing that 20 degrees is just fine. But the 54 minutes is not. The 54 minutes is in minutes, and they said to put it into degrees. So here's the deal. Remember the conversion we did just a few minutes ago between degrees and radians? I'm going to use that same process. I'm going to take my 54 minutes and I am going to multiply. I need a conversion between minutes and degrees. That's right, that's this one right here. Because I know 60 minutes is 1 degree, don't I? So, since I'm trying to get rid of minutes, what do I put on the bottom? Right, I put minutes. And the 60 follows with it because the 60 goes with it. Which means the 1 degree is on the top. And when I go ahead and figure this out, I get 0.9 degrees because those minutes canceled. Got it? Which means I have got 20 degrees and this 54 minutes converted to 0.9 degrees, didn't it? What do you think you're going to do between these 2 degrees to get the final answer? Yeah, you're going to add them, which gives you a total of 20.9 degrees. So 20 degrees and 54 minutes is equivalent to 20.9 degrees. Cool? All right, let's go with a second one. Let's see. We have 274 degrees. We have 18 minutes. Whoops. Might help if I put the minute mark there, agreed. And we have 59 seconds. Now, directions haven't changed. They want me to convert to degrees. So, I have 2 things to convert to degrees, don't I? There's a couple of different ways you can actually do this, all right? So I'm going to show you one way, but there are others. So follow along with me. I want to convert my 18 minutes into degrees. So I know 18 minutes. To convert it to degrees, again, right? There's my conversion. So what goes on the bottom? Yeah, the 60 minutes goes on the bottom, the 1 degree goes on the top, doesn't it? Minutes cancel from top to bottom, so I have 18 over 60 degrees, don't I? Good, so the 18 minutes we just converted. Check. Now the 59 seconds. I don't have a conversion that takes me from seconds to degrees, do I? But I do have a conversion that takes me from seconds to minutes. So, what's going to go on the bottom? Good, 60 seconds, which means 1 minute on the top. And why did you put the seconds on the bottom? So you can cancel the seconds from the top and the seconds from the bottom. And now I'm in minutes, aren't I? But I don't want to be in minutes, I want to be in degrees, which means you've got one more conversion to do. I need to go from minutes to seconds. And I already have that conversion. We've worked with it twice already. And we put it on the bottom, minutes on the bottom. Why? So we could cancel minutes from the top and minutes from the bottom. And now I've got my seconds converted into 59 over 3,600 degrees. Cool? Okay, which means we have 274 degrees plus, right, because we add these guys together, plus 18 over 60 degrees plus another 59 over 3600 degrees. And yes, they're going to want a decimal answer, so you get to your calculators and get me to 4 decimal places. And let's see if you come up with the same answer I did. I have 274.3164 degrees. Yep. Just had to check my work. Good? So this is one way of converting your degrees, minutes, and seconds into just degrees. All right? There is another way, yes, but this is one way. Cool? Okay, so stay tuned because we're going to go back. Okay, so let's go backwards. Now they want us to convert to degrees, minutes, and seconds. So let's look at the first one. They gave us the full degrees, 31 degrees and 4,209, 31 and 4,296 10,000ths degrees. Okay, so here's what we need to understand. We have 31 full degrees, don't we? And we have partial of a degree, right? This 4,296 10,000ths is a partial degree. It's not a full degree, is it? So, one thing we need to understand is we already have 31 degrees. And what we need to do is find how many minutes there are, and then seconds, because seconds is smaller than minutes, and minutes is smaller than degrees. So, I'm going to take this decimal, this 4,296 10,000ths degree, and I'm going to convert it into minutes. Yes, because minutes is just below degrees. So, I'm going to take our decimal, and yes, over 1, and I'm going to convert it to, what did we say? Minutes. So, how many minutes are in a degree? That's right. 1 degree on the bottom, 60 minutes on the top. We put the degrees on the bottom so they cancel, don't they? So this will give me, when you get on your calculator, this gives you 25.776 minutes, doesn't it? Good. So check this out. This partial degree gave me 25 full minutes, didn't it? So I know I have 31 degrees and 25 full minutes, but then I've got a partial of a minute over here. 776 thousandths, right? I've got a partial of a minute, which means I can take this partial of a minute and convert it to, convert it to seconds. So let's take this partial of a minute and let's convert it to seconds. So what's my conversion? 1 minute is equal to 60 seconds. Excellent. Which means we are going to take, that's right, 1 minute on the bottom, so the minutes on the top and bottom cancel. And I've got 60 seconds on the top, don't I? And when you do your calculator work, you'll get, you'll get 46 point something, right? Sorry, I have it rounded in my answer, but I'm going to figure this out. Why? Because I want you to see something. So you get 46.56 seconds. So here's the thing. I have 46 full seconds, and then I got partial of a second, don't I? So in our civilian world, we don't go below seconds. Military, they use a little bit of a different method, but they do go below seconds, so to speak, because they need to have pinpoint accuracy. So here's the deal. When we have these seconds, we are going to round like we normally do. So this would be approximately 47 seconds, wouldn't it? Which means my original problem of 31 and 4,296 10,000ths of a degree is actually 31 degrees, 25 minutes, and 47 seconds. Cool? Okay, so now we've got this one to do. And if we notice, again, we have full degrees of 178 full degrees. And now we need to take our partial and we need to convert it. Our partial degree, and what are we converting it to first? That's right, we convert it to minutes, because minutes is the next unit down. So how many minutes in a degree? 60 minutes in 1 degree. What do I want to cancel? Degrees. So you put degrees on the bottom so you can cancel, which means those 60 minutes go on the top, don't they? And yes, you get your calculator out and you end up with 35.964 minutes, don't you? Okay, so that means you have got 35 full minutes. Yes? And then you've got a partial of a minute. You got this 0.964 partial of a minute. So I need to take that partial and convert it to, excellent, seconds. So, that's right, 1 minute on the bottom, so I can cancel the minutes from the top and bottom. 60 seconds on the top. And when you do this, you end up rounding it to, so I'm going to say approximately 58 seconds. Cool? So, here is our conversion from degrees into degrees, minutes, and seconds. So for you GPS people out there, you boaters, you pilots, here is how you do the conversion that you probably punch into a computer and let it do it for you, but here's how you do it. Cool? Okay, so hang in there. I have got a couple of formulas for us. Okay, so let's talk about finding the arc length of a circle. Now, believe it or not, you already know how to do this. So hang in there and I'll show you why you already know how to do this. But let's read this so we have an idea of what's going on. It says the length S, so they're calling the length of an arc S. It's intersected on a circle of radius r by a central angle, theta radians, and it's given by, all right, so let's back up a little bit. So it says basically the length of an arc, and they're calling it S. So, here's our arc, because the circle doesn't have any sides, right? So this is our S. And this arc is intersected on a circle of radius r. Okay, so where's the radius of a circle? Agreed. The radius of a circle starts at the center, right, and goes out. So this is my radius r. By a central angle. Central angle means the vertex of that angle is at the center of the circle. So, here's the thing. This is also r. My theta is right here. That's your central angle. And notice, theta has to be in radians. Got it? Theta has to be in radians. If it's not in radians, you need to convert it. So now they're saying, so here is our formula, right? Here is the formula for this arc length. And so we're looking for S. Now, before I get there, I'm going to sidetrack you a second. Do you remember how to find the perimeter? Well, it's not called perimeter, is it? The circumference of a circle? We spoke about it a few minutes ago, right? The circumference of a circle is 2 pi r, isn't it? R is the radius. Do you agree? And what was 2 pi? Yeah, 2 pi was the measurement of a full circle, right? And this is in radian measurements, isn't it? 2 pi is all the way around the circle, isn't it? It's like they took your initial side and went all the way around until it met back at 0 degrees. So, the circumference of a circle is found by taking the radius and multiplying by the angle of the circle. To find the arc length, I'm going to take the radius and I'm going to multiply it by the angle, the central angle, which is the same that we did over here, except over here my central angle was the entire circle. But in this case, my central angle is not the entire circle, it's a portion of the circle. So I take the central angle and I multiply it by the radius in order to get this distance for the arc length. Cool? It's the exact same formula as the circumference formula for a circle. Exact same formula, except in this case, I'm not taking the full circle, I'm only taking a part of it. Okay, so hang in there. I got one more formula that you pretty much... Okay, so let's take a look at this one. Now we're talking about finding the area of a sector. So let's read it. The area of a sector of a circle, we're going to call that area A, and the circle has a radius r, and a central angle theta radians is given by. Okay, so we've got our radius of the circle, we've got our central angle theta again, and yes, it's in radians, so if it's not in radians, you're going to have to convert, right? So here's the deal. I want to now know the area of this piece of pie. With me? That's what I want to know now. I want to know that area of that piece of the pie. And here's the thing. You already know this. So sidetrack with me, shall we? How do you find the area of a circle? That's right. Pi r squared, right? Okay, so r is clearly the radius. What does pi stand for? Yeah, that's not a full circle, is it? It's half of a circle. Pi is half of the circle, isn't it? We didn't take 2 pi, we only took half of the circle to find the area of an entire circle, didn't we? So check out what this formula looks like to find the area of a sector. I am going to take half of theta and multiply it by r squared. Pi was half of the circle. This formula said take half of your angle. It's the exact same formula, except one of them is for the full circle to find out the area of the full circle, and the other one is just for a piece of the pie. So, a couple of ways that you could write this particular formula. Some people like to write it this way. Some people like to write it this way. You know, it's totally up to you. And sometimes when you're dealing with fractions, this might be the better way to go, the second one. Good? Okay, so hang in there. I got some examples for us.